Boom. That works. Close that. Yeah, buddy. So this curve will control the cache and the speed of the actual simulation. All right, folks, here we are in 3D Max. So get right into it. We've got our Ninja Dude, and we've got our post here. That's already I've pre-cut this thing. The goal behind this is we want to be able to treat the high speed, high movement of the animation in a way where we can manage it. Let's start by setting up our thinking particles. We've got our ground, got our dude, and our pillar here. So choose get a layer, highlight that in blue, get our particle systems, thinking, let's put it out. All right, I made a little button for open properties. It's pretty easy to do. Instead you just select it, go to properties. Just so everyone is on the same page, we're going to go down here to key mode toggle, right click. Make sure we are on film or 24 seconds, or I'm sorry, 24 frames a second. Let's change our start time. Let's do 1000 to 1100. That is set turn real time off. We want the playback to be off. Let's go to our custom unit setup. Go to system unit setup, and we want to be at 0.1. 1 unit equals 0.1 of a meter. So that's set. And now let's go to our TP UI. So master dynamic. We're going to put user defined start frame as 1001. That way we can always kind of zero out our system by landing on the beginning of the timeline at 1000. Let's turn these off, everything. So we're going to be able to control the viewport visualizations. Next up is the subsampling, which is the most important in this. We're going to start at per frame just to get the ball rolling, but eventually we are going to be at 240. So that would be 10 times or 10 substeps per frame. So we want to keep it at per frame, and we'll remember to bring it back to 240 once we start getting into the dynamics and the solvers and whatnot. So let's set up our hierarchy, go to our groups. I'm going to do this a little different than I usually do. You know, with time and experience comes evolving. So the way I name and set it up is a tiny bit different. I think it's more, it's a lot more clear and efficient. So I'm going to start this off with, let's see, Devman Kick. His name's Devin. Get it? Dev man. Now the next one, we're going to stack these groups. So the next one's going to be 0, 0 for, this is going to be anything under this container group. It's going to be for the base setup. So it's going to be for the base sim, the basic rigid bodies. So what I do now is for every group that is a container, it's going to have an underscore before. And any group that has a defined particle that's pointed to it, it doesn't have an underscore, so it'll be either the 0 or the number associated with the container group or anything else you want to put in there. So the first one is, so we've got our main container group, so everything's inside there. Second one is this. I'm going to name this RBDs, so that'll be our main RBD sim. And next one is going to be, like I always do, we're going to do underscore 00 neutron. Okay, and here, let's do one more group here. And then this container underscore 00 active. Let's put a group in here. I'm hitting Control G, or you can just hit create if you want. I like shortcuts. Shortcuts are awesome. All right, so in here, I'm going to make N for neutron. So this is going to be where the actual particles exist. All right, this is now we're no longer dealing with containers. This is going to be, let's just do a generic global name, anim, and color that kind of actually keep that saturation down. I'd like to just put that like a dark gray. Shift drag, and this is going to be the post. Post as in this guy right here. The actual, let me turn off the ground here. This is the post. And I'm going to recolor that green. Okay, and that's just the neutron one. The active group, we're going to do 00_A for active and post. So that's the active post. I'm going to color this appropriately green. All right. Now we have our first system set up. We can move on and start building out from there, down from here, but I want to just keep building out the main group hierarchy so we don't have to later. Make another group underneath the master container, devmin. Let's do _01. This is going to be for the bris. The bris. Okay. Organize, guys. Organize. Very, very important. Good thing to know. Everyone loves when you organize. So, the bris, same thing. 01. Neutron. Group. 01. Active. Okay, same thing here. Gonna make group 01_N debris. And just click and drag, copy that, and then rename this to A. Color these, let's do like a dark. I always like to keep the neutron particles, or all the particles or objects that I don't want to have affected by any kind of outside forces like gravity or dynamics. Kind of like a dark muted color. And then the active ones are always some bright, and they kind of correlate with the neutrons. So in this case, I want to do like a bright purple. Neutron's going to be dark purple. I should probably do that with the post. So green would be like a dark desaturated green for the post. Yeah. Cool. So we got that set up now. We have debris, RBDs. I'm going to do one more. Control G. This is going to be named _utils. Utils for utilities. This is going to contain surface particles, activation particles, surface position. We need that, and then we need like one called a break position. And I'll show you what that's going to be doing in a minute. I believe we need that. I can't totally remember, but we'll get down there. And this one is collision environment. That's where the that's where the ground's gonna lay there. So once we have that in there, we don't have to worry about building any major hierarchy in groups. We can always add later, but it's good to just start off with that so you don't have to worry about it later on. Cool. So this is the basic and hierarchy, group hierarchy that I like to build off the bat. Now you could say this is a black box, makes it easier, quicker, and then we could always add and take things away later. But now let's start to build our dynamic sets. First one is, I'm just going to keep hitting Control D, Control D, Control D, Control D. All right, so just want to make a nice little tree here. First one is, I like to just kind of let's correlate it with the group devmin kick system. Yeah. Cool. All right. And let's start to rename this. I've learned from being at Scanline for such a long time, and thanks to Joseph Scar, who really kind of pushed that pipeline forward and really made it extremely efficient. So a lot of this the naming conventions and habits that I got into was because of him. So thank him when you see him. Give him a beer, buy him a beer. I think he doesn't like IPA. I don't think. So cache, we're gonna do, well, let's start from the bottom up. Let's do cache 0, cache 1, cache 2, NT3 2, cache 3. Underneath, I'm gonna collapse that. Underneath Devman kick system, gonna make actually let's organize this. Let's just expand that. That's the cache 3, okay. We want to go ahead and save it first. Okay. Tab, we're going to go get a memory node. All right, this is pretty important. And again, this is another trick, you learn from being around some other among superstars of the effects world. So you'll learn a lot, a ton. Actually, I learned more around being around these guys than by myself or in any school. Right? So this is my knowledge that I've attained from other people's knowledge, right? So I'm just passing down the torch. Paying it forward, people. All right, we want to make a memory node, and we want to name it master or something like that. It's very important. So first off, we're going to make 2 integers like I always do. We're going to name it gravity and friction. Keep those there. If you don't know what those are for, it'll come back later. So now save it. This is our base system. Good idea to save this as a black box, and then you can re-import it to any system you want. If you want to save the black box, you can just hit master dynamic, and you want to go over to these icons, hit save, and save wherever you want, right? So we're going to name this Devman kick lesson, right? And then you can save it. Exist or create, that just takes anything in your system and points it to the group, and it allows you to create the groups with or without any particles pointed to it. Good. So now next is let's start importing our objects. So in cache 0, I'm going to pull this down. I'm going to rename this _birth. What I do now is again, similar to the groups, every dynamic set that is the potential to be a container, I put an underscore before, okay? Container meaning anything inside this dynamic set would be other dynamic sets that contain logic, right? Let's go right click. We're going to pull down the groups. No, we're not going to do that. I don't have to do that yet. We need object to particle. And let's do, oh, no, actually, my bad. So inside birth, we're going to put a dynamic set since this is a container. And we're going to name this import. Just drag that in there. Okay, now we're going here. All right, let's do, we need to bring in this dude, the ninja guy, 00 n anim. So I'm going to correlate the import node, whatever I use, object to particle, with whatever group it's going to be pointed to. Just makes it easier that way, right? And I'm going to make a mass node. I want to just define the mass as soon as we can. Size is mass. Pick that dude, okay? Select him, object to particle, instance shape, point him to anim. So, note on why I'm naming him this way is automatically when you want to point or find a group, let's say right here, you want to pull down, you want to access the groups up here or define a particle using a group. Already there's a bunch of stuff here. This could go down for miles later down the line, building on top of this. Well, I want to quickly find the group that I want to point it to. Now, if these were all just named lowercase random shit, it's going to be very difficult to find. I'm a little dyslexic, so I can't really see it too well. So I have to really, my face gets shoved up against the monitor just to see which particle I got or group I got to point it to. So that way, these underscores automatically I know those aren't going to be. I'm gonna already I scratched that out, right? Because these are containing groups. I'm not going to point this to a containing group. So those are already off, out of my mind, out of my sight right now. So I'm just paying attention to the numbers. Obviously, 01, we're not going to touch yet. So now what's left is just the zeros. So now my focus is just in this area. I know it might sound silly right now, but trust me, once you have time that's burning, and you have deadlines, and you got people under pressure, and it's late at night, you can't really think, you got a ton of other groups to manage, this is helpful. So at least to me. So we want to point it to anim, so that's there. So let's check out the groups. Actually, what we forgot to do, go back to the groups, and we want to make this a neutron. And let's start to play with the friction. So I'm going to do friction dynamic is going to be 20. Static is 35. Doesn't really matter too much between the both. I just like to put them the same. Now the voxel grid, 3 we're going to keep it for the post. But for the guy, for the dude, the ninja, we need a more accurate representation of his surface. So I'm going to make him 32, right? All right, that's good enough for that. I'm going to save it again. Okay. Now I'm going to do something a little different with the post here. I'm going to do a layer to particle. This is cool. I think they introduced this in actually TP6. Let's get our layers here. Let's rename it to 0, 0. We're not going to do end post. We're going to do active post. We're going to use the end post later on, right? So this is going to go directly into this guy. And since we're here, let me just adjust the group. So select the group. I'm going to hit frozen. Reason is it's still going to be active once it gets activated or involved in anything outside of it, like any type of environmental interaction. But frozen says if it's not moving, the solver ignores it. So that's helpful with time saving. All right, friction, I'm going to put this to, again, it's wood, or no, it's concrete. It's not really going to be very friction-y. So let's do 14, 14, or, 20. That's good. Keep everything. I'm going to keep the voxel grid. Let's do 8. 8's probably a good one. 3 is always good to start out with, but I've already done this scene here, so I'm just going to cheat until you guys do 8. 8's a good number. All right, same thing. I'm going to click and drag the mass, put it to here. Layer particle is pretty cool, but you got to be careful. What it does is it just grabs. You go asterisk, get your string, get your asterisk in here, hit enter, and then find your group that you want, or the layer that you want it to associate it or import the objects. I'm going to do post high. That's where this is laying. But you got to be careful because, see, now it'll grab all the object in the layer. Already import them. Done. But you got to be careful because if you have any hidden objects, they're going to be still imported. TP doesn't know if they're hidden or not. So just check that. Make sure you're managing that well. All right. Now we want to point this to no, we don't worry about that. So instant shape's always going to be on, and the group is pointed to a post. And the cool thing is I can delete this, right? I can point it to another layer if I wanted to, and it's always going to be pointed to the same group. I don't have to update it like I do object to particle, right? If I delete this guy, I have to continuously update this. So layer to particle is nice, but it's somewhat limited. You can't really use neutron animated mesh inside here. So mainly it's for lots of objects, destruction. It's good to have. So That's the main purpose, I think. All right, dudes, dudettes, people of all the world. I'm gonna move one more, and it's gonna be, let's just click and drag this, and it's gonna be a collision environment. That's just our ground. There it is. So I'm gonna go. Oh, did I? Careful! I didn't point that back to my post there. Collision environment. Let's do asterisks. That's just kind of a universal expression for get everything. And where is it? Collision environment. All right, make sure you have. Nope, that's the wrong one. Boom. All right, make sure it's in there. Instant shapes on, and point this to collision environment. All right, we've got that stuff friggin' imported. Let's turn off the actual objects. Leave the TP on. Go to master dynamic. Double check everything's good. Save it. Get rid of our layer. Here, go frame 1. Nothing's showing up. Why? Because these groups are set to global. Always want to turn these off. So point this to none. Point this to none. All our particles, at least. We don't have to worry about the containers. You can leave that all like that. Post, point that to none. All right, we got it. So wireframe, make sure they're in the right groups. Good. Color is good. Awesome. And also, let's scrub forward, make sure the dude is working. All right, so he's not jumping around. What you got to do with Alembics is make sure the guys don't kind of jitter around and do anything funky. That's not what the animation is. So what I like to do is turn back on the actual object, play it back with the system, lines up. Dude, perfect. All right, that's all nice and neat and tidy. Save it. Next up is we are going to do this, okay? We're going to go back to our birth dynamic set. We got our import dynamic set here, right? Here's our lovely setup here. Go into birth. We're going to do, we're going to put out a node here, okay? We're going to rename this anim node, okay? Drag it above. Anytime you put something outside of a dynamic set, I like to just keep it above just to manage it. Let's get our layers. I'm gonna get our our ninja dude. Let's pick the guy. All right, I'll show you why I'm doing that in a second. This is a nice way of managing it as well. We need to emit, right? To put some surface particles on his foot. Actually, let's get the post here. So he kicks it. We're going to use the force of his kick. We're going to use the velocities from his foot. We're here, go into birth, hit Control D, do another dynamic set. Actually, let's just drag that down there. We're going to rename it to emit. Actually, surface position. That makes more sense. Surface position, okay? We can go inside here, get a position born. I need a surface position, so I need to throw these guys on the surface of this object. And I need to define, using an operator, position to particle. Let's get the particle to particle. This needs to know what specifics. And no, wait. Yes, that's right. That is correct. Okay. Position to position. All right. So off the bat, put this to face. And what I'm going to do, I'll show you in a second, actually. Okay. So this needs an input, right? It needs an actual object. Well, instead of, I'll show you why I'm going to do this, but I could theoretically use an anim, right? I could do this, and I can do particle shape. But I'll tell you why I'm not doing that. This is the ability to access another set that's going to attach to a surface, and I'm going to just recycle the same node. Since putting it outside, I can input it into any set I want, and then whenever this changes, let's say it has to change, it'll update any kind of dynamic set down the road. So that way I'm not constantly changing, going into each set and adjusting anything. So, but anyway, so I'm going to take the node, drag it up to this box here. I'll let go, creates an input right here. Node goes in here. Okay, so that works. Let's point this to surface position, pistol shot. Let's do like 100. Lifespan, arbitrary large number, speed 0. See how that works. Save it. Let's get our thinking particles on. Turn this guy off. All right, surface position. Let's change this to ticks. Cool. So that works. But it's all over him. So what I want to do is isolate it on his foot. Okay. I'm going to do one of two things. I'm going to do a couple things here. Let's get our sim guy again. Close this for a minute. So what I did was, you can see I got some modifiers here, but I selected, what you want to do is you want to select the faces that you want to have get the particles to, right? And go down here, set ID. So right now it was at 1. We want to change it to 2. I'm going to hit so that's all we need. We just need this stuff around his foot, because when it comes in contact, there's nothing else that I need. Okay. And hit Control I and just make sure that's all set. Set ID to 1, right down here, just so we are in the safe zone. All right, so another thing I did was, you don't have to do this, but I did it for speed-wise. Oh, let's invert that again. I just deleted the rest of it, right? Cap the holes, right? So now we just got a foot. Still has the alembic data. So this thing still moves. That's a foot. Oh my God, it's a floating foot. Cool. All right. Let's go back into TP. So let's go frame forward. Turn on TP here. Okay, so now we got stuff on this foot. I can actually raise that up a bit. Let's do 1,000. Oh, let's turn on real time. So uncheck that. And let's do 300. 500. And change this to, I'm going to do drops, just so we can see the velocities. So obviously we need to attach them to the foot. Let's go back up here, and we need to do surface follow. Let's do floor node into here. Now we need a particle input. I'm just going to go to groups, surface position. Since we made them already in here, got it there. So I'm going to drag these up here. And actually, I'm just going to select this guy, right click, and go make dynamic set. Just because I like to organize it that way. That way I can go inside here. I can add whatever I want. I can add rules and everything. It doesn't have to clutter up this area here. Okay, so let's just name this attach. Let's see how this looks. Boom. Right? All right, it works. So we got our particles following the surface of the foot. And the lines you see is since I defined here as drops, but you could just do ticks, right? So now we got it following the foot. But I like to keep it at drops here, so I can see how fast things are moving. Plus it looks cool. Right? Okay. Next, let's start to create the dynamics of this. Okay. Next, let's make our dynamic system. Go to cache 0. Hit Control D. Let's go 0 out here. Rename this to underscore system. And just throw out a couple dynamic sets here. First one, system memory ops. Memory op for operators. Memory ops. So since we already created our gravity and friction up here, the first set inside the system, I like to make. Let's get our. I like to make a memory, and I like to define any kind of rules that pertain to the variables that I make. So in this case, what I like to do is I like to keep the friction on all the time. Friction, high friction in any type of rigid body object, structural type of build or whatnot. Always keep the friction on, but it only evaluates on the first frame. That way, you just put a condition. You just go particle age. This says just on born, so it sets it up for the first frame until I tell it to do something else. I always like to do this. So let's get our friction, and I'm going to get a Boolean, put that into our friction, and turn it on. I don't need the depth. And I want to apply that to everything in 0 active. Particle there. Okay, cool. So what this is saying is, all right, I got my friction. It's going to be on in anything underneath this group. So everything in this container, this friction is going to be applied. But now, again, we didn't apply the actual force, so that has to be applied later on. But once we do, this is already set up. All right, so the next one is, this will be explode. That'll be where I put our like force and stuff. This one will be forces. That's the gravity and friction. And then this one will be solver. I used to name it SC. I'm working in Houdini now, so that I've got that, computer science lingo going on, but I like to apply that to here. It's more, I think it's more proper anyway, so keeps it nice and organized and manageable, right? Save that. So let's do forces first. Let's get what we're going to apply it to. It's going to be our active. Tab, we'll do force. This will be gravity. Boom. We're going to do on. This is where we're going to define our variables. So memory, gravity output, friction output. So the on goes to gravity here. So now, I'll do that in a minute. So friction, nope, wrong one. Particle to here, turn on. Okay, friction to on. Let's put this to a giant value. Let's do like 1500. And let's get a point helper. We need a vector. Direction. Vector. Let's do our gravity. Usually it's 48 at this scale. So a value of 48 will have an accurate falling gravity falling speed. But in this case, we're doing some high speed retiming shit. So let's do 140. That was a pretty good value. So let's do 140. Now the direction is we just need to point it in the right direction. -1z going down. Boom, done. So friction is going to be applied to anything in this container, which then, see, it's on. We've got variables turning it on and off. But that's being defined here. If I turn this off, friction, this is going to be turned off. But we'll keep this on, and that evaluates the first frame until I tell it not to. Okay, we got that set up. Solver. My favorite love. SC. I'm going to point this to RBDs, right? Anything in here. And then for the deflector, collision environment. All right, that's set up. So before I even do anything, I like to just import my objects, double check to see if they're working, all the data's there, they're moving, they're pointed to the right groups. System, build a system, build the basic fundamentals of a simulation. We need gravity, you need a solver, and any other types of stuff. Then we could build the explode. But before we do that, I can do this. I'm going to actually turn off the friction, disconnect there, so now we have gravity applied to the active. Well, yeah, we'll see. And since we've got the guy moving, let's see if it works. So, save it. Boom. That works. Close that. Yeah, buddy. Right off the bat, it looks pretty fucking dope. Sweet. That piece is acting funky. Let's check the pivot points here. Boys, girls. Just like that. Go here, effect pivot. See if anything moves. Nothing moved. Okay. So these are good. Always check your pivots of any kind of rigid bodies. Always have to be centered. Okay, open TP back up. Now we know everything works. Interaction works. Now we can start. Now we got to change this to samples per second, 240. Well, let's keep it on per frame because we still have to build the explode. But this will have to be coming soon. And if your system is a little bit weaker, you could probably bump this to maybe like half that. So 120 might be good, but there's a reason why we got such high ones. But if you're struggling, if your system's struggling, you can lower that. It'll probably still work okay. All right, explode. This is where what we want to do is, if you saw in the video I had, actually let me pull that. All right, so this guy kicks it, right? So you can see the larger pieces I was able to keep pretty relatively still. That's the result I wanted, and then I want some smaller pieces getting flown out. Now there's a chance some of the small stuff could potentially leave. I could just make a velocity threshold to say if you're this big and you're this small, but I wanted to give it more impact. So what I'm going to do is I'm going to take the speed and location of the foot particles, and I'm going to say when you're close by, use a force and just explode out in the direction of these guys that these guys are moving. So whatever direction the foot is moving in, it's going to force them to fly out. So that way we'll do a post, right? And I need, save that. I need a P search, and I need to point this to the surface position. So this is just looking for the foot particles to give it a radius. I'm going to put this to about like 8. Particle to particle in there. I want and I want a force. And let's get the on input particle here. I want the found PIDs, and I need a particle data node. I need to access, so essentially, basically, this guy is looking for, it's pointed to the surface position, so now it's focused on those foot particles. And it's saying within this radius, which is, let's check to see how big that is. Circle. Make sure this is pointed to group that's on, or layer that's on. Hit the circle. If I drag that out there, you can see over here, this is the value that I'm working with. So 8 is about that. So that's not bad. That's about the area we're looking at. Right? So this guy's looking at a radius about that big, and it's saying, okay, once I find it, I'm going to affect you. with this output. So that way we could just, for now, let's test it out. Let's make this like 500, 35 variation. Right, so I need to, and once it finds it, I need to access that data. So that particle, I need to get the position and the velocity. So if I do direction from velocity, so I need to grab the direction from the foot particles. So however fast they're moving, that velocity data is going to point it in this, and it's going to attain, direction information. So that's how it works. It's the vector. Velocity is a vector, so it's moving in a from A to B in world space. So that defines a direction. Position to position, and let's see what that does. I'm going to turn off the solver just so we can speed things up. And I'm going to turn off forces. And I'm going to hide the post. All right. See, that works. We're going to top down. We can see what's going on. This foot comes out. Boom. So we got a nice little spread here because these guys over here are grabbing probably around the toe, right? Or the stuff, his foot, whatever part of his foot hits first. Again, with these, the outside. So it gives a nice variation there. All right, another thing we want to do is I don't want the big ones to be affected. So we need a size threshold. Let's get a threshold node in here. These are all under conditions, by the way. Threshold right there. Let's go to our outputs of the size. I need to grab the data there. Let's go one forward, wireframe, or edged. Let's hit the UI, hit I, or you can go here and go show info tooltip. That way I can roll over. What's going on here? There we go. Click. Now we get all the data. Go to size. So that's 8. That's 6. That's 3. I think I don't want anything bigger than 3. Anything underneath the size 3 to be affected. So let's just do 3, and I want everything inside. So now I can introduce an AND statement. Boom. I go, if you find the radius, if you're within my radius, and you're this big, do this. So now if I play this back again, boom, just the little ones. So, or at least the ones that are big enough that I could see, and small enough that they don't take the whole thing down. Okay. Now, one more thing one more thing. A couple other things, but the next thing I'm going to do is egg timer. Because what happens is, as long as that foot is around those particles, the other objects, like the concrete or the pillar, it's going to constantly keep evaluating and making that's and affecting it with using this force. So I just want the force to run a couple frames. So you want to do the output to start. Make sure this is inputted here. So out of running, just put, let's do 1 frame. That's enough. And hit single. So that way, the second it hits, it just runs for 1 frame, pushes it outwards. And if it comes close again, it won't affect it again. All right. One more thing we need to do is we need a memory node here, because since we are turning on friction here and gravity, the goal behind that is, and we'll watch this video again. So these guys here, so all this stuff here, that friction never turns off. That's the way it keeps it intact, and it's not flying out everywhere. And all I'm saying is, if you're big enough, if you're this big, just keep the friction on. These little guys are going to be obviously affected by the force. And also I need their friction and gravity, their gravity to turn on, their friction to turn off. So that's what that's what the goal behind this system is. So here, let's just do the on input. We're going to get gravity and friction. I just need a Boolean, turn gravity on, and shift drag friction off. Now, let's just rename this to size. All right. And we could just take the on input to this output. All right. So that should, if I turn that's on, that should still work. Nice, that works. Okay. It's always good to, once you start to introduce your forces and any kind of outside influences, forces, gravity, whatever, noise, put your subsamples to where they should be. Otherwise, your results are going to be sometimes drastically different. So we're already on that. That's good. I'm going to turn the solver on and pray this thing works because that's a lot of subsamples. All right, let's play it back. I'm going to cache this actually. Turn the solver on. Everything is good to go. Right click, cache record. I like to always correlate this with the version. So right click, V0001, cache 0, all set, save. All right, it finished. So, and that actually wasn't that bad. That was like, yeah, look at that, 240 seconds. I mean, subframes, 2 minutes. I've gotten, here's my specs for you guys. Got the i7 3.9. All right, boom. So that's sweet. That works. That's nice. And let me turn off the these guys. Look at that shit. Bam. So that's cool. Actually, it's pretty cool to, let's get this guy on, turn off the modifiers. Bam. So that's nice. So it is pretty much doing what I want it to do. Although I was hoping that these guys up here would release. Actually, I know what to do. I know what to do. I want these little ones up here to, when they move, just to kind of get affected. Well, the reason they're not is because our P search is not in any sort of distance within the foot. So right now they're just still being affected by the friction. I want to make one more rule that says, let me back up here. Let's let's get some information here. We'll go one frame forward. I'm going to zoom in. I'm going to go hover over here, hit the letter I. That activates the rollover. I'm going to click, get our velocity. Let's zoom into the little particles here, little pieces here. Speed, 14. Next frame, 6. Well, it doesn't really matter. They're moving slow, but here's the idea. I'm going to get the system, hit D. I'm going to let's put it in between forces and explode. I'm going to rename it to velocity check. So I like to name it vel check. It means velocity. I'm checking the velocity. Let's go post. Get our velocity, threshold, velocity to there. And I'm going to say anything that hits a velocity of 4.5. All right. Vel. I'm going to shift click and rename this to size. And it has to be, what's that size here? Size is anything within 3. Same thing as the explode. So it's got to be if your speed hits this value and your size is within these values, then do this, which is we need an and turn this on, then pump that into there. then turn gravity on, friction off. Same thing we did in the explode. Gravity on, shift click, gravity, friction off. Okay. Let's cache this again. I'm going to version up and cache this again here. And again, just keep it for our records, guys. Always want to keep a record here open. Save it and cache record. Okay, this is done. That splits open. I don't like that. Pretty much nothing I like about it. So I'm gonna go in. Let's actually, first of all, just for safety's sake, let's raise this to like 10,000, just in case. Explode. Let's have this run for 2. And vel check, we're gonna do, let's do just 1.2. That's how big the sizes have to be, or small. Put that to 5, make me comfortable. And let's try it one more time. Save it. All right, this looks pretty sweet, man. Bam. Now, I kind of lost some of the fast moving stuff, but we'll go back to that. I want to move forward. I'm kind of burning up time here. That looks pretty cool. If we just play that again. Yeah, we got some really nice interaction. We can go back, clean this up, but the main focus is I want this, you know, it just looks proper for now. Next up is debris. I'm going to get this debris here going. We got that packaged up. We got the first cache. We can close these so we can get space open here. What's up with that? Okay, let's go. Save it. I'm going to up the version here. We got version 3. Okay. So now we're going to debris. First thing is I need to create some surface particles on the posts, the inside faces. That way I can control and emit off those particles that are on the surface of the inside faces however I see fit. Right? I could do dust, I could do pyro, smoke, other types of debris, any type of control. So this is going to be underscore surface born. In here we got 2. This is going to be born. Another one's going to be attach. So similar to what we did with the foot. And I'm also going to turn off the post mesh so we could see the particles here. Okay, boom. Let's get this pretty quick. Save it. Let's grab our A post. Tab. We're gonna do a position born. I'm gonna Alt left click to zoom out a bit here. This is gonna go into N debris. Do position similar to what we did. So surface position node. I need to grab the inside faces. I define them for you guys, so it's 2. That is the inside faces of the post. Particle to particle, position to position, and then I need the particle shape of the post. Make sure you put this into here. And yeah, and let's just do I like to put this in here. Size. So I don't want, you know, sometimes if you have really tiny pieces, they go crazy or they do some, the behavior is all out of whack. This thing's going to be emitting off of them. So I want to put kind of a safety net in there. Let's do anything, has to be above 0.5, the size for it to emit. Anything underneath that, it won't emit. So just, you know, keeps the calculations at bay. Okay. So let's do our whole kind of routine. Let's do about 100 lifespan. Okay. Now let's see if that works. Let's make our group ticks. Yep, that works. So let's put them at dots. Okay. So I'm gonna turn the post back on just to see. Yep, they're on the inside. As you can see, they're in the inside faces. All right, now we need to attach them. Oh shoot, I put those in attach. Let me rename this here. That's attach. This is born. Each particle, each piece of the post is getting surface particles distributed, right? Well, each of them get, I think, about 100 per object, right? Well, the problem is some of these the surface area, the bigger pieces, covers a lot more, obviously. So the distribution of the particles, it's distributing based on the surface, or no, based on the amount that I defined it as. Rather than saying, okay, here's my surface, I'm going to distribute evenly, just as if it's a big piece or a small piece. So that creates kind of an awkward kind of set, because you can see here, these guys are being, they're being distributed, but you see there's huge gaps in between. So I want to grab that surface data. So let's start with getting an object, so it can distribute it evenly. Particle to particle, it's got to be particle A. And then we need objects here. And we need a geom object. And that way I can grab, you can see the surface area here. And all I need is, I'm going to use a math, so I can manipulate that area here. And let's do a shot. Let's put the shot into the float, and I'm going to see float. I need another input, float, and we're going to do division. Float to surface area. Let's get a float node. So now it's 0. All right. So now you can see, let's just do 0.2. You can see, nice, doesn't matter how big the piece is, they're all being distributed nice and evenly. Boom. How you like them apples? All right, now we need to attach it. Attaching is kind of cool. It's interesting. So the way I'm going to do this is first I need my N debris, which are the purple guys here. And I need to say, please attach to this group, okay? So I need to set my reference from the bris, and I need to parent it to the group. Now, normally you'd probably grab, you think you got to grab the post to that. It doesn't work that way. What we're going to do is we're going to go back into Born. We're going to create a data channel, okay? So let's get a data channel node. I'm going to throw it to the output of the N debris. So now this it's pointed to this group, and I'm going to use the integer. All right. Now before I attach, I connect that, we're going to go into we're going to hit the devmin kick container group, okay? And we need to create a data channel, and we're going to name this. We're going to go over here. We're going to go into this little box here. We're going to go call my parent, and make sure you set this to integer and hit add. All right. You can see it's got a channel 0 and my integer, or my parent name. Now, since N debris is within this group, which has the data channel here, now I can access this. So data channel 0. Any more channels I add will be defined by this number. Keep it on 0. I'm going to put this into post. Basically, this is saying, okay, thanks for that input of the particle. Who am I attached to? Oh, that's my parent. Okay, specifically. So now you can go into here and it can access the my parent output. All you do is set ref to and from. Now I have set the reference point to each particle based on their parent. Now I can get that information by going get ref, not getter alignment, get ref. Okay. Boom. And P attach. I think, how does this work here? I got to do from the reference particle to there. And before I start scrubbing forward, I'm just going to highlight these, right click, and go make dynamic set. P attach. All right, now we got our nice little organized attachment system. Let's see if it works. Let's move forward. Oh. Ooh, it's a chugging. It's a chugging. I do remember it takes a while, especially on the subsamples. So what we got to do, it'll chug. So, you know, let's just temporarily switch the per frame with subsamples just to see if it works. Okay, so that works. See the surface particles following. But we cannot keep it that way. Notice how the ninja dude's jumping around like a ninja, like a moron ninja. Let's put it back to subsamples. Now we're gonna cache this, okay? We're gonna cache this since it is a pretty heavy cache, but we need that information. That's pretty critical. So we're in version 3, cache 1, save, and go. So this might take, depending on your system, let's see, it might take like 10 minutes, maybe. So I'll see you guys back here. All right, so that took a little longer than expected, but it's totally worth it to have this information. I decreased the amount significantly, so you might not need that many on your surface. So let me just... these guys really kind of behave how I want them to behave. So again, just use your discretion. Now that we have that data, it's pretty smooth sailing from here. Turn that off. So we got 2 caches set, right? We got the main sim, we have the surface particles. Now it's time for the debris. So we want to make a new, first of all, let's turn off. Let's check that again so we don't have real time on. Make a new set within cache 2. So we want this set to look at this cache. Same with this. Any cache you have, you want to stack it right underneath so they look at each other. So this one is underscore debris. And we're going to make a couple sets in here. First one, let's do emit. This one's going to be gravity and flow. Emit, start off with, we're going to grab our neutron debris. Let's change that back to a darker color. And purple's a little hard to see in the viewport, so let's just do kind of a light blue. Okay, debris. Now we need a position born. Pretty much, you know, just we'll go through the same, similar to what we do here, but this time these guys are going to be reading. We need the position particle. These are going to be reading just the velocity of the neutron. So point this to A, and we'll give it a pistol shot of 1 for now. Get a large lifespan, do the whole works. And we need speed and direction. Direction is going to be pumped into the velocity output. So get your velocity into direction. And speed is also going to be in velocity, but we want to manipulate that and be able to multiply it up and down. So again, get a math helper. And we need 2 floats. So 2 float inputs. Velocity and speed float, and changes to division. Let's see, good value to start. Let's just use 1 for now, so it's 1 to 1, and we can go up and down. So the lower you change this value, it divides it, so it's going to be a lot more powerful. or it's going to multiply it more. And gravity, we'll just actually, I'm just going to, well, I'll just make a new one here. A debris, or I'm just going to put it under an active, just in case we always want to add more groups. So force here, 144, and a vector, -1. Flow. All right, so this is cool. Since TP6 came out, or was it 5? Either 5 or 6. They introduced the flow solver. Now, this is great to use for debris, simply because if you lower the values enough, or you don't give it enough, you lower it, you take away the fluid properties enough to where you just use the collision of the surrounding geo, and also it just gives it a much nicer look organically. So you don't have to build this bunch of math logic rules to try to mimic a natural looking type of scattering. So I'm gonna get a flow group. We need a flow solver and a flow boundary. So these three are your, there's a lot of, I'm just gonna, okay, if you've never used flow, this is probably a great time to start. The very basics. This is gonna be the very basics of flow. We're just gonna be using it to collide with our ground and our post. All right, we just need this to be to collide it with. So if I go to flow boundary first, we need to point these to the flow solver we created. And let me just, so you can rename this there so you can clearly see in case there's more solvers. You can either add outside objects or just use the group. So I'm going to use active post and unyielding. Keep these are good kind of default. We can adjust that later, but we'll do flow group. We point this to the solver, and we want to point the particle. We want to tell the which particles we want. So a debris, that's going to be our flow group. So off the bat, I'm going to change the smoothing radius. I don't want to go too detailed into what each parameter does. That's a whole another session or video. But just keep the solver type by default. Depending on your version, you know, you can, depends on what you have, but pretty much any one of these is going to work. All we need is just a tiny bit of viscosity is good. Keep these at default pretty much. Boundary, we want to kind of mess with these things, so just give it a little bit of bounce. Friction, we want some friction on the boundaries. And adhesion, that's kind of a cool thing to play with. Just kind of sticks. It's a different property than friction. Adhesion just allows you to get the flow to kind of accumulate and stick to the surface. And just adhesion, sticky. It's a sticky property. Other than that, that should be good. So let's check this out. But before we do that, I want to emit this stuff on velocity. So get that good old egg timer. We want to do reached, and we need a random. So, and we need to get our frames input. So these are our frames now. Good value would be like 0 to 15 frames. So it's going to emit. Each one of these guys is going to tell the position born to birth a particle between, it's going to choose between 0 and 15 frames per particle. So switch to animation so we're not cycling through particle to particle, and then a threshold. We want to grab our velocity value and start it at that moment. Let's give it a safe value of 2. I don't have to be too accurate here, but I'm gonna turn off the show mesh here. Save it, and let's see how this looks. Actually, before we move forward, I'm going to disable flow. You always want to test your system out before your solver kicks in. Good coffee, good coffee. Okay, we got that. I'm gonna play it back. It's gonna be chuggy, guys, because we're at 240. We're at a high subsample rate. All right, so that's working. So we want all that stuff to kind of emit, but we can control that later. All right, that's working. Cool. Now we can test it out with the flow. Actually, one thing I forgot: flow boundary takes in consideration the post, but I also want the collision environment. So I'm gonna pull out the box here, and I'm just gonna add it to the group window. Turn that off. All right. Let's save it. I'm gonna enable flow, and let's cache it. Cache this stuff here. Actually, right before that, kind of a weird trick I noticed that if you go to the master dynamic, either leave it at none or dots, whichever one, and do force this setting just temporarily. Let's keep it none and cache it. Sometimes it does the caching decreases a bit, but notice that in certain situations. So I'm just gonna hit force this setting for now. Don't forget, because everything's gonna be invisible, so don't freak out. Right click, cache record, and we're on version 4. Okay, cache 2, save. All right, that took. Let's see, that took about 8 minutes, almost 9 minutes. Not too bad. Actually, that's really not too bad considering all the pieces that it's interacting with. So let's play this back. Looks pretty cool. Let's turn off the let's get rid of the visualizing that guy. Let's do a play blast. Oh, I don't want the edged faces. Turn that off. All right, let's check this out. So it looks pretty cool, man. That's cool. The idea is to give this some dripping type dust, particulate, extra tiny bits of debris that kind of distribute throughout the rigid bodies. Like, I don't like the dripping; might be too much, so we can go in there and adjust that. Once we give these things shape, you'll be able to see it a lot clearer. The buildup on the bottom's kind of interesting, but which is good. We want that, but it looks like it's getting a little bubbly. So you can adjust that by, or you can fix that by adjusting the smoothing radius. Probably the tension. No. Yeah, you could put the tension up a bit. Let's try that. 0.02. Smoothing radius, I'm going to do this to 0.75, and that should be cool. Emission, I'm going to, it's the frames. Let's rename this to frames. Let's do like 12. That way it might calm down the dripping a lot more. So let's try this again. I'm going to sim this one more time, and then that should be good to move on. Because because you could always go back and spend a ton of time adjusting it to as much as you can. But the time spent right now, I just want to run through this as fast as I can, so the video doesn't run for like 3 hours because we can keep going on this. But next up is going to do shape, but I'm just going to sim this one more time. Let's version up, just so we don't, in case we want to go, just in case I need that sim again. I drastically go too far from where I was. Just to make a new version 5, cache 2, and cache record, run 5, good, boom, done. Oh, right, check this out. This looks better, pretty cool. Next thing, I'm gonna play this back. Let's do a play blast preview. All right, that's cool. I like that. And also, you can see you got a little bit of interesting buildup. You want a little bit of that piling up too, but since we're not going to be really focused on that in the view, you don't really have to worry about it too much, but you can get that a little bit of a pile up, which is cool. All right, next up is shape. We're going to make the shape of this stuff. We got to define that. That's pretty easy. So this is the last step right before we time remap it. And time remapping is pretty cool. And that's also relatively quick. So we got 3 caches so far. We're going to make another one under cache 3. See how this is very important? This is very useful to have a hierarchy that's already predefined right now. You can set it up so you can do as many caches as you want. What you want to avoid is caching everything at once because it's so hard to control. It's extremely hard to manage. So, you know, this is how my experience has been the best way to go. Because once you have everything set up, you can always go back in, recache, just recache everything, adjust some settings, and recache. That's all it takes. So shape here. Let's get our A debris. A debris, and we need a geom instance. I'm gonna reference some shapes here. We need a size. And we need alignment. Here, this gives it a random alignment on birth. Let's do particle age. So once we start instancing shapes, they're all going to be aligned or oriented in one direction. Alignment's default random. We need a random alignment on birth. And then we got that set. Now we need the shapes. Since I'm a nice guy, I also have these for you. But the idea is just to get a nice variation of size. Keep it. And I've got some mesh that's optimized. Actually, should just select all these, convert to editable poly. Okay. You want very basic shapes since these are super tiny. Nothing complex. But that is the extent of the detail that you want. Not too much. So we're going to take this. Select these guys, geom instance, pick object. I'm hitting H, by the way. If you need to get that list, you go pick object, hit this up here, select my name, and then anything in here and pick. So we got those in there. Size, leave by default for now. Let's check out to see what these guys look like here. All right, so that's cool. Obviously pretty big. I'm going to turn off, I'm going to select the post, turn off show mesh, and debris, select the debris and turn off the dots, just so we can actually see what's going on. All right, so we got a majority of that for now. Since this stuff gets started at about 15 frames in, what I'm going to do to debug, or not debug, first apply this stuff quickly so we don't have to go back and forth real quick. Instead of a debris, I'm going to point it to end debris. For now, this is temporary. Reason is these particles are visible on the first frame. Do show mesh. What we're doing is I just want to define the shape, the size, and the scale of it so we can see it first. And I'm going to put real time on. So go to master dynamic, uncheck this, and we're going to reveal the size input here. And we're going to make these nice variation of size. So what you do is we need a random, we need a curve, 2D, okay, and just a float. Start to connect these together, value to Y value here, X value here, we don't need that, particle here, animation, keep it 0 to 1 for now, curve, float, boom. All right, the curve, what this is going to do, we're going to define a nice, this is 0 to 1, 0 to 1. We're going to make a nice, let's see, add point here. Just going to make a ramp here. So the idea is to give a percentage of, we're going to vary the size. So instead of just applying a variation to it, because any kind of variation, it's still, you still have a kind of an even distribution of percentage. So, you know, no matter where you put this, it's always going to have the kind of an even distribution look of variation. So what this is going to do is going to say most of my particles are going to be this small, and then a tiny percentage of it, maybe 10. This looks like 5 to 10%, are just going to be this size, or a larger size. So we're going to make this ramp here, make it Bezier. No, how do you change that? Here, okay, right click, hit smooth Bezier, and move. Just going to make this ramp just like that. See how that looks. All right, so this random, this is where you're going to define the shape. So at this, on this whole area here, it's going to be the lower end and the higher end, right? So obviously you got value 1 was the lower end, this is the higher end. So this value is going to define the larger size, or the sizes that are more on this end, on the right side, than the left side. That is the most layman way and the best way, the best layman way I can come up with. So nothing too technical. Let's start. So these are the larger pieces, these are smaller pieces. Let's see how they look. Frame first. All right, so you can see that is the, let's do 0.8. Those are too big. 0.2. Let's change this back to 1. All right, so you can see that's nice distribution. There are too many bigger pieces, so I'm going to open the curve up. Make sure you go back. Let's make that even more crazy narrow. Just like that here. Even more narrow. Like crazy narrow. Let's see how that looks. All right, so that's looking better. So you can see that distribution of variation is nice. And I'd like to actually go in here and add like 35% just to give it even more. So this is probably the best way. Let's see, 0.3, how'd that look? And then this float value will just multiply it overall. So if they're too small and you don't want to go back into any of these, you can, or too big, you can multiply here, put 1. or 0.1, right? So now you can actually see them a bit. Let's just do like 0.03. And the larger ones, those are still too big, so I could just go 0.99. Right, 0.995. All right, so now we're talking here. 0.9965. Let's see how that looks, because these are like dust particulate, and just a tiny percentage are larger little chunks. And the camera, like, you know, we're going to be about this far away, so this is a really nice look here. And the tiny ones stacked together, it's going to be nice, like dust particulate look. All right, all right, all right. Let's see how this looks. So I'm going to change this back to A debris. And we will put this post to show mesh, turn this off, and then that's all good to go. All right, I'm going to cache this. It should cache relatively quick. And everything copacetic. Cache record, version 5, and save. All right, yeah, see, that's going pretty decent. And we're at a high subsample set, so it's behaving pretty good. All right, this is done. Let's see how this looks. Whoa. So there they are. Might be a little too small because you can really barely see them. What we could do, instead of going inside the cache, watch this, guys. All right, we're outside here. Going to make molt, size molt. Gonna go, yeah, A debris, size. We need to get these size and put the float really fast so we don't have to go back in and recache. Okay, I need to access the size already. I'm gonna turn this guy off. Go about to 1019. All right, since we got real time on, so just be careful though, because we're starting to get heavy. So once we start to adjust things real time. All right, let's see how this looks. Let's see if this works. 0.1. Wait for this to update. Too big. Okay. 0.005. Still a little too big. 0.002. That looks a little better. You turn on the post. Show mesh. Let's keep the mesh on. Might just be a little bit more. Let's do 4.004. Let's go back. I think it looked better. It's 0.008. You could see them together with the post. All right, let's see how that looks. I'm going to play this back, and then we'll go move right on to the timer mapping. All right, let's check this out. This is looking pretty nice. Once they start to build up, see that dust particulate fall out. It could be a tiny bit bigger. You can go in and readjust the shape here. Just add some more on top of there. But I'm going to preview this for now and see how this looks, and then we'll move. That'll be it. Next up is the time remap. And then we're good, man. And then you can go back and pretty this up as much as you want. All right, that's cool. Now on to the really cool shit. All right, here's the deal. So in order to do this, go your TP here. You got your main cache. Make sure this is all set. Everything's packaged up, right? Well, we want to get our cache time input. Okay, this is where this is where we want to feed in the time curve data. So, what I want to do, okay, a couple things. I want to do a float, not a floor. I don't want a floor here. Float. Put this above here. Put our cache time in here. We're going to do time underscore remap. Okay. All right. So here is our sim cache. Okay. This is where we had the foot, and this is where we import it into our system here. What you want is the same Alembic cache, but this one is going to be the one that you render and the one that you apply your animation curve to. So here's the guy, and you can see I already applied a time curve on it, but for Alembic we want to select the guy, and you have these options here. Playback type. It's going to be set to default original range, which is 0 to 39. Right? That's way back here. Right? 0 to 39. Okay, so what I did was for the sim guy, for the sim cache, you do custom start. So I keep the same animation, but I need to start it a lot. It would, I'm specifying my start frame. With the anim, you go to playback graph. What you need to do is keyframe the what frame range you have already. So if it's 0 to 39, I would start this at, make sure you got auto key on, and you do frame. Actually, let me, so I don't screw this one up, I'm going to copy this guy, color him green, no, blue. Okay, and playback graph, I'm just going to delete all the keyframes. So now we got here. Playback graph, you want to keyframe start here at 0. Frame 0, and if you want to go to 1039. Well, I already have the keyframe in there. 1039, and we'll do 39. If you open up your curve editor, or you can go graph editor, new track view, and then you can customize it there. Put these to linear. So now we've got the appropriate graph starting at the appropriate frames, and now we can manipulate this graph how we want. Now remember, the important thing is this needs absolutely crucial that this Alembic cache needs subframe data. Okay? Or else you will get very annoying, inappropriate stepping when you start to stretch this out. So if I stretch this curve out already, he slows down appropriately. But if he has per frame subframe data, you're not gonna, or it doesn't have subframe data, you're not gonna be able to get this to work. That's why we cache this with a lot of subframes. So these both match each other for the most part. So this is what we're gonna do. You're just gonna go back to your curve editor. You're gonna find a moment where this guy, let's go to A, I'm gonna add a key. Where this guy kicks it, boom, got a key there. Pull it back, and the second he pulls back, basically we're trying to find a spot in time for us to slow down. So we got two keys. This area here, I want to really slow down. I want to grab these two. I want to stretch them out. Right? I'm gonna zoom in. Adjust this curve to get it nice, smooth transition in and out of a slow. Right? Let's change this to real time playback. See that? We got a sweet ass time remap. Pew, slows down. And no stepping. No, not at all. So the farther you stretch this out, the more stepping you're going to get. So if I just go like that, whoop. Where am I going here? Okay. I stretch this out real far. Pull this down. It actually does even a better job. Look at that. I could slow it down super far, doesn't? So that's important, right? If I just undo that, okay. All right, here's the next part we got to do. Okay, we got to link this to this node right here. Okay, so let's do this. Take this guy, take the curves, select all the keys in here. We're gonna go to Edit, Copy. Okay, close this. Now what we need to do is paste it on top of this value so it creates the curve. So first of all, I need to select this guy, go to Auto Key, and just make a keyframe by moving the value and zeroing it back out. Okay, so what that's going to do, it's going to automatically create a keyframe. We need that keyframe so we can just apply our already copied curve on top of it. Select the thinking particles. That needs to be selected. So when you open up your track view again, it's right here, right? DevMan kick system, float, Bezier float, time remap. So make sure we're selecting the time remap helper. So there's our keyframe, right? It's 0. There's our keyframe. Select the keyframe, just go paste, and we want to instance it, right? So now here it is. Here's our curve on the guy. So anytime we update this guy, turn the auto key off. Look, if I drastically change this like this, and I select the TP, it's already updated. So you want that control. It's not too complex. It's not too crazy technical, but it's straightforward enough so where it works. And I like it. I like it. There's many other ways to be able to do that, but this is a quick solution. It's very simple. It might not be too stable when you build up upon it. You add more layers and detail to it, but for now, this is great. Now we got one more problem though. If I turn, if I got TP, I frame forward. If I have that on, we got a problem here. Okay, where's the particles? If I disconnect this, go 1, there it is. Okay. Why is that? Well, what I did was these keyframes on this guy, the values start from 0 to 39 because that is the frame range of the animation in the cache, right? I'm just starting it up. I'm just applying it. So the problem is this cache starts at 1000 to 1100. The time remap goes from 0 to 39. So what I want to do is I'm going to put a float in here. Cache time, disconnect this to here. And I'm just going to put this to 1,000 because I want what this is going to do is going to push these values up to 1,000. So now it starts at 1,000. So if I go first one, there we go. See how this looks here. Bam. So there you go. Now it slows down. There. So that's cool. So that works. So let's play this back and see how this looks. All right, man. Check this out. That is badass. Woo! That's sweet, man. So you can notice we got one tiny more we got one more thing to solve here. See how the cache stops? Well, we want it to continue going. Obviously, we have enough information. We got 100 frames of information. The animation we manipulated, the curve that we changed, or the curve that we manipulated, only goes to 39, right? Well, that's easy. Very easy to do. Pretty much open up your curve editor again, select the thinking particles. Oh, excuse me. Or just this guy. Select this guy. Go here, okay? And maximize this. And actually, let's turn off TP here. All right. So zoom out here. We want to have one more keyframe. Make sure this is untouched, right? Because this is the end of the animation cache. What we could do, hit A, add a key here, M from moving. Move this up, make it linear. Move this up to, you know, make sure the curve is appropriate here. We want to put this to 100 down here. It's easier to see here. To 100. So this value is going to be 100. So we keep this the cache continuing. The animation is going to stop because it only has 39 frames of data, but that doesn't matter. Add a little Bezier curve here. So at least we could tell the TP cache to continue going all the way to the end here. And actually, since we're slowing it down, we need some more frames here. So let's do 1150. Right? So I want to bring this out to about here. Let's change this back to linear. So what I'm doing, I'm just visually looking at this curve. I'm not applying any math, you know, any kind of math numbers and anything. That's, you know, you can if you really need some extreme accuracy, but I like, if I'm just creating something like this, I don't need to crunch numbers here. All right, so that ends at 20. We've added about 20 frames. All right, 1120, 100. So there you go. And let's play this back and see how this looks. Let's organize that. Save it. I'm going to hide this guy. Let's get TP. All right. And this foot's annoying, so I'm going to turn off Anim Show Mesh. Actually, I need that. Yeah, so I'm going to turn that guy off. So DevMin, let's move him back to the center. So this is the guy I already had. Not using that one. Okay. So turn off the Anim here. All right. Let's play this back here. Sweet, guys. Check this out. Here we go. Here are the results, man. Boom. Slow down. Boom. Time remap. That's sweet. So this could obviously be improved. We can add more detail. Yeah. That's cool, man. All right, we got a nice build up here. Really nice impact. That's cool. All right, guys. There you go.